So in today's lesson, we're going to cover latitude versus longitude. It's the first lesson for our mapping unit. All of these lines that we're talking about today are imaginary, just like state, country, and county lines are imaginary. They're not physically there unless carved by like a river or a mountain or something. But latitude and longitude are imaginary lines that we use primarily to help us plot and locate locations around the world. So when we think about a grid, right, a grid has both horizontal and vertical lines. The latitude and longitude are lines that create a grid around the Earth to help us, again, locate locations or describe locations. Latitude are the horizontal lines. I try to remember this by thinking latitude, attitude. You snap back and forth, side to side. Latitude lines run side to side. The 0-degree latitude line is called the equator. It goes through Ecuador. Again, that's 0 degrees, and it's at the widest part of the Earth. So think about when you're about to cut an onion, for example. When you put an onion on its side, I don't know about you, but I tend to cut straight in the middle, the widest part. And now I have two separate spots. It's just kind of like the easiest spot to cut, again, because it's just right in the middle. You can easily divide it. Maybe you're going to use one half of the onion tonight and the other half of the onion tomorrow. You can easily separate it there. I'm going to get to something else in a second. So that's what our equator is. It's the widest part of our Earth, and it's 0 degrees. If your location is north of the equator, then you have a northern degree, like 38 degrees north. If you are south of the equator, places like Brazil, Peru, all of Australia, then you are in the southern hemisphere, hemi meaning half, sphere like globe. So you're in the half of the Earth that is south of the equator, and your latitude degrees will be south. We are in the northern hemisphere because we are north of the equator. Same thing with Europe. Yeah, so Europe and, the Arctic. We measure latitude from 0 to 90 degrees because 0 is our equator. That's think about math class when you're plotting something on a graph. 0 is like your x-axis, and 90 degrees is directly above you. Think about that right angle. 90 degrees would be directly above. You can't go any further because when it comes to latitude, we measure up, highest point 90. So let's say you're right here where my mouse is. That might be 80 degrees north. Well, what if I'm on the other side of 90 over here? Would I be, 100 degrees north? No, I would be 80 degrees north because the highest degree is 90. So that's something special about latitude, is that the highest point is 90 degrees directly above you. Imagine the right angle mirroring itself, right? So we never go past 90. If you have a degree over here, it would just be, again, something below 90. Longitude are the vertical lines. Think like long hair running down. These start at both poles and end at the other pole. So again, going back to the onion, with an onion, its widest part, you flip it on its side and you can cut it there. Well, something like an orange, let's say you're going to cut an orange, but you don't want to flip it on its side. You're going to cut it the normal part with the little pit on top. You could cut it anywhere and you're going to get a half. That's the same thing with longitude. I could cut my globe in half anywhere and I would get half of the globe on one side and half of the globe on the other. So it doesn't really matter where our 0-degree longitude is. However, sailors had been using the Greenwich meridian just meaning longitude. It's another word for that, longitude line. They had been using that, so that's what we went with. And that became our 0-degree line. So from Greenwich, England, if you are east of Greenwich, England, you are in the eastern hemisphere. And if you are west of the prime meridian, you are in the western hemisphere. So that's how longitude essentially works. Longitude does go from 0 to 180 degrees because, again, think about that circle. In math class, you learn that there's 360 degrees in a circle. So if you cut it in half, okay. Sorry. I got rudely interrupted by WeVideo saying I ran out of time because I didn't purchase their subscription. So they have my money now. Anyways, what was I saying? Longitude, when you from your prime meridian, because you can cut the world in half, right, at the prime meridian, take 360, take your circle, divide it in half, you get 180 degrees. So if you are east of the prime meridian, you can be as east as 180 degrees, which is directly behind the prime meridian. If you are west of the prime meridian, you can be all the way up to 180 degrees again. So these numbers are much bigger, and the reason why, again, is because you can split your world in half anywhere when we do it at the prime meridian, and when you cut your world in half, you get 360 degrees. When you cut it in half, you get 180 degrees. Going back, though, yes, with latitude, we did split our world in half, right, at the equator, we did split it in half, but remember that we're stopping at the poles because that's our highest point. So that's half of 180 now. So we're stopping at our highest point, which is 90 degrees. It's directly above us. These rings that you see here, they look like lines, but they're actually rings. They go around the whole world. Because they go around the whole world, if I'm over here in the United States on this line, which is 1, 2, 3, 4, 5, 6, 7, 8, 9. So this would be 60 degrees north, right? Because I'm in the northern hemisphere. But if I'm over here, technically I'm now, hang on, I'm east. I always forget my directions. I'm east of the prime meridian now, which is okay because I'm still on the 60 degrees north ring. So latitude goes up to 90 because 90 is the highest point, but longitude does not. Longitude goes all the way to 180 degrees. So hopefully that makes a little bit of sense. I recorded this actually a few times, so I'm kind of confused on what I said and haven't said. So I'm going to go back and double check I made everything right. All right. So because latitude has the equator that splits our world into the northern hemisphere and southern hemisphere, and the prime meridian longitude has or splits the world into the eastern hemisphere and western hemisphere, we are going to get 4 quadrants. One quadrant is going to be both in the northern hemisphere above the equator and west of the prime meridian. The northeast hemisphere is going to be north again of the equator, but east of the prime meridian. The southwest quadrant will be south of the equator and west of the prime meridian, and the southeast quadrant will be south of the equator and east of the prime meridian. So with that being said, because we have 4 quadrants, if you're a location in one of these quadrants, you will always have that quadrant's directions. You'll be, for example, let's say here in the United States, let's say we're trying to find Virginia. Virginia will always have, no matter if you're in Winchester or Culpeper or Blacksburg, you will always have latitude points that are degrees north as well as longitude degrees that are west, because we are in the northwest quadrant. So that's what those the directions mean, right? So mapping using latitude and longitude, together those two make a coordinate. The first number in there, or the first degrees in there, is your latitude, and that should be followed by either north or south, degrees north or south, because again, latitude is telling you how north of the equator you are or how south of the equator you are. So it should be a number followed by degrees north or south. The second number in there is your longitude in either degrees east or west, because it's describing how east or west you are of the prime meridian. I also remember that latitude comes first, longitude second, because alphabetically it's in order. LA for latitude is alphabetically first, longitude LO alphabetically second. So hopefully that that helps you remember when you are doing this on a test or trying to use this in real life. Sometimes it's simpler because remember, latitude only goes up to 90 degrees. So maybe you have a number or a coordinate like 30 degrees north and 120 degrees west. Well, that 120 can't be the latitude because latitude goes up to 90, so that must be longitude. But maybe you have a trickier coordinate like 30 degrees north, 40 degrees west. Both numbers exist for latitude and longitude, right? Latitude goes up from 0 to 90, and longitude goes up to from 0 to 180. So it can be a little tricky to remember those. Just remember latitude comes first because it's alphabetically first. All right. And okay, and then we had some practice. The practice is in class. I forget what box number, but when you come into class and you look at the absent board, I'll have it listed in there. So just recapping some main points, and I have them written over here too. What I want you to know for mapping is that we have 4 quadrants of the Earth, northwest, northeast, southwest, southeast. We get them because they're either north or south of the equator and east or west of the prime meridian. I want you to know the names of our 0-degree latitude and 0-degree longitude line. 0-degree latitude is the equator, and 0-degree longitude is our prime meridian. Sometimes the SOL, if you're taking that, asks you where the prime meridian is. It's Greenwich, England. Just think because England has to have their noses and everything. I don't know. Let's see. Okay, the equator and prime meridian are both 0 degrees, but the equator is 0 degrees horizontal latitude. It goes through places like Ecuador. Think Ecuador equator. And the prime meridian, like I said before, goes through Greenwich, England, and that's 0 degrees longitude, which is vertical. I want you to know that latitude and longitude are imaginary lines used to help plot points or describe the location of something. And I want you to know that latitude runs horizontal and longitude runs vertical. I also want you to know that latitude is parallel while your longitude touch at those points. They touch at the poles. I want you to do that practice because I want you to know how to plot the different points and also how to read the latitude and longitude. So the practice that you'll do has you both plotting and also has you practicing the points. And I want you to be able to read, and find coordinates. So that's part of the practice. And yeah, I think we touched everything else. Latitude lines don't touch, they're parallel, and longitude lines do touch. Please let me know if you have any questions. Again, we have the practice in class, and that's all for today.